This is Lab 1, Charged Tapes in Physics 2212. In this experiment, two pieces of charged tape are prepared and their interactions are observed and analyzed. And two more of our goals are determining how much excess charge is on one piece of tape and to simulate the results through a Vpython program. We see the preview of the findings where the charged clear tape has a net positive charge and the tape is also deficient of 7.3 E10 electrons. The fundamental principles used are Newton's second law and Coulomb's law. Newton's second law states that the change in momentum over change in time equals the net force. And Coulomb's law states the strength of the electrostatic force that attracts or repels 2-point charges and is inversely proportional to their distance from one another. We can see more about these two concepts represented in the picture shown here. The net force is the addition of all forces on an object, and Coulomb's law emphasizes the closer two charges are, the stronger the force between them. There are some important assumptions in this lab. The tape acts as a point charge. Next, the point charge is also located at the center of the tape. Then, the procedure for creating charge is the same for both tapes, so both of them will have the same amount of charge. And finally, air resistance is ignored. And lastly, the reasoning for the model. Because the tape acts as a point charge in the code, we can model the U-tapes as singular point charges in the code. The system is a suspended U-tape. The surroundings would be the held U-tape and Earth. Then at equilibrium, the net force on the suspended U-tape is 0. Here are the procedures of how the U-tapes were prepared and how one U-tape was suspended by the other U-tape. Here are the main observations from the lab. What is important to remember is the U-tape had a positive charge, and this was determined because it was attracted to the pen with a negative charge, and opposite charges attract. Here we can see the calculations performed in this experiment. The formulas used to get these numbers is shown as well. The computational model was done through Vpython. Here we can see the code for the constants, gravitational force, electric force, charge, deficient electrons, as well as the amount of atoms. The same formulas we saw in the calculations portion of the presentations are the same ones used in the code shown here. This slide shows the visual aspect of the code along with the ratio of deficient electrons to atoms. On the left side, we see the results of the code, and on the right side, we see a free body diagram. The free body diagram looks pretty similar to the result of the code. Possible sources of error include inaccurate measurement of the separation distance and of U-tape length and width. The suspended U-tape could have not been parallel with the other U-tape, and there could also be errors due to rounding. If the electrons had a positive charge and the protons had a negative charge, the electric fields would change. But even though the charges would be opposite, the observations would not change. This time the U-tapes would have negative charges, so they would still repel because they are like charges. And then the pen would have a positive charge, but since it is still opposite of the two tapes, the pen and U-tapes would attract. It is important to handle the charged tapes as little as possible because when objects come in contact with another, electrons are transferred. If we touch the contents of the experiment too much, it could skew the results of the experiment. Touching the U-tape would cause surface electrons to transfer, decreasing the positive charge of the U-tape.